Okay, so today we're going to talk about multiplying binomials, specifically radical binomials, and that's where we're going to end up at the end of today. Before we start with that, though, we probably should start with talking about how you distribute radicals. And this problem that I have right here, I know it's a distribution problem because I have parentheses, and I have this plus sign. Now normally, because there's parentheses, we have to do the stuff inside the parentheses, but we should know that I can't add this radical and this radical together because they're not the same square root. Like, they would have to be 6 and 6 or 7 and 7, but they're not. So because they're different and they're not like terms, I can't add them together. So we're going to start out by distributing this radical 3 to both terms. And if you remember, how we multiply radicals is we multiply the square root times the square root. So I'll get 5 radical 21 plus 7 radical 18. And again, they still don't have the same square roots, so we can't add them together, but we could try to break them apart. Unfortunately, the only things that break up 21 is 3 and 7. And I don't know what the radical of 3 is, and I don't know what the radical of 7 is. So this thing would just stay the same, so we're going to bring it down. 18, fortunately, can break down into something. It'll break down into 9 and 2. And then we can take the square root of 9. And the square root of 9 would be 3, so I'd have 7 times 3 times radical 2. Well, that would give me 5 radical 21 plus 10 radical 2. And this would be my final answer. The reason I know that this is my final answer is that this square root and this square root is different, so I can't add them. And I've simplified as far as I can go. 21 only breaks up into 3 and 7, and we don't know those square roots. And 2 doesn't break anything into except 2 and 1, and I don't know those square roots either. So that would be my final answer. Let's try another one of these problems. Okay, so let's do this problem. Again, we know that it's a distributing problem because I have parentheses and we have addition and we can't add. So we're going to distribute this to both terms. If you remember, multiplication, the outside numbers will multiply, so I'll get negative 6. And the insides will multiply, so I'll get radical 50. And again, same thing over there. 2 times 5, well, that will give me 10. And then 5 times 40, well, that's going to give me 200. And on this problem, again, we can't add these things together because they have different square roots. But we may be able to reduce them. So we're going to try to reduce them. 50 will break down into radical 25 and radical 2. And 200 will break down into radical 100 and radical 2. And so we can then simplify it a little bit further. Negative 6 times, well, the square root of 25 is 5. And I have 10. Well, the square root of 100 is 10. Now we'll combine as much as we can. So I'll get negative 30 radical 2 plus 100 radical 2. Well, negative 30 and 100 will give me 70 radical 2. And that, because I can't simplify any further, is my final answer. Again, we were able to add this time because both of these shared like terms or like radicals. Okay. Let's do the next problem. So we've kind of mastered, we've had 2 problems on just distributing. Now we're going to try a problem where we have to distribute over a binomial. Okay, so we got a lot of stuff here. This should look very much like the last chapter. And this time, if you notice, it looks like a distributing problem, but this time I have 2 things in front. So we're going to first distribute that over and see what we get. That would give me 10 plus 10 radical 7. Because again, this doesn't have a square root, so the outside numbers would multiply. Then we'll go through and multiply these. Well, this would give me negative 2 radical 3, because I have that negative radical 3. And then radical 3 could multiply on the inside, and I get 2, or whoops, I'd get negative 2 radical 21. And then I would look across. Well, I can't simplify 10, that's going to stay. I can't simplify 10 radical 7, so that's going to stay. I can't simplify negative 2 radical 3, so that's going to stay. And I can't simplify negative 2 radical 21, so that's going to stay. And I can't add any of these things together because they all have different square roots. So that would be my final answer. Some of your final answers might have a lot of terms, so just realize that. Okay, so we're going to try 2 more problems. This one is very similar to the last example. We have 2 things in front now, so they're going to distribute over. Again, we get to multiply the outside numbers and multiply the radicals. So I'll get 6 radical 18. Then this one I get plus 10 radical 6. Then we'd have to multiply the 5 to both things. The 5 would give me negative 15 radical 6. And then negative 25 radical 2. So now we're going to look across. I notice here that those have like radicals, so I could combine them and get negative 5 radical 6. I notice nothing is going to divide radical 2, so I can keep that one. Radical 18, though, can be broken up. That could be broken up into radical 9 and radical 2. Well, the square root of 9 is 3, so I'd get 6 times 3 times radical 2. And then we would have 18 radical 2 minus 5 radical 6 minus 25 radical 2. Well, when I look here, I see something else that would work. This and this, they're like terms now, so I can combine them and get negative 7 radical 2 minus 5 radical 6. Now these can't be combined because their square roots aren't the same, so this would be my final answer. Let's try one more problem. So this is the last problem. I would distribute over again and get 9 plus 3 radical 5. I would distribute this one over and I would get negative 3 radical 5 minus radical 25. Now 9, I know, that's nothing. These can combine because they both have like terms, but I have a positive 3 and a negative 3, so they actually both cancel this time, or give you 0 radical 5, which you know is nothing. And then you have the square root of 25. Well, the square root of 25 would give you just 5. So now I have 9 minus 5. Well, 9 minus 5 is 4. This is a very special type because we started out with a whole bunch of square roots and ended with just a normal number. If you have that case, it's very similar to our difference of squares in our last chapter, or the binomials that when you multiplied them together, you got a new binomial. Be on the lookout for types that do this, and try to see if you can find the pattern, because it's going to be very helpful for us when we move forward. So try these problems.